for the next hour on this session of Lunch and Learn. You will hopefully learn a bit about Don by discussing some, shall we say, colorful opinions that he had concerning a variety of selected topics. Before we begin, I would like to introduce a few folks and our format. I'll be a moderator along with Kristen Dean. She's going to join us as a moderator on a couple of the selected slides. We also have one of the family members, his son, Sean Arabian, on as a guest, and we are reserving about 15 minutes, the last portion of this, for kind of a free flow organic discussion, and maybe Sean would share some things about his father to give us a little more insights. So we are very glad to have Sean with us this afternoon. The original inspiration from this actually came from one of my informal mentors, Gene Hayjay, who I'm not certain has made it on yet, but he provided me some slides that Don had made many years ago, and you'll see one of those in the beginning of our presentation. And finally, we can't thank enough our public affairs person, Laura Aguilar, for her assistance in putting the entire presentation together, and also for being a gentle reminder to us that we need to keep moving on slides if we kind of do bog down in some of our discussions. We are recording this event so that it can be looked at by others, and if someone misses it, they can watch it. We will have a format of the raise your hand function. So please, when we get to the slides and you have an interesting item to talk about, please raise your hand and the moderator will acknowledge it in the order it's received. We'll try to get to all the hands, but again, Laura will keep us moving where we need to keep moving to stay on our time frame today. There is also, of course, the chat where you can continue discussions and have a free form in the discussions. Does anyone have any questions before we get started, or any comments from any of our people that put this together? All right, hearing none, I'll ask for the next chart, please. So just wanted to go about our format, which we kind of covered. Why is Don relevant? You'll see in the next chart why for Spaceport Integration specifically, he's important and relevant today. Our format is, the quotes are from this oral history that anyone can go and look at, and we've kind of classified them into these areas that you see here. The moderators will read a quote, their selected quote, and if we have time, maybe a couple of the quotes. They're kind of lengthy and wordy, and so we'll stumble through the quote just to get the gist of it, and then open the floor for that time frame. And then again, we'll have the 15 minutes closing remarks with Sean, and kind of a real more organic and free flow there. Next chart, please. So this is why I think for Spaceport Integration, Don is so relevant. This chart was created. This is he was an artistic kind of guy, and this is his hand drawing of a series of charts that Gene gave me many years ago when he did a cost analysis presentation at, I think it was Fat Boys in Cocoa Beach. And so this Spaceport, Florida, he says, this is a nice idea. You got to get the best cost. Do it better than anyone else, which is kind of what SI is trying to make happen out here at Kennedy, right? We're trying to bring on these players, do it better than anywhere else. And even then, he identified the competition down there as France, Russia, Japan, and other U.S. sites. So to me, this was just mind blowing to think in 1993, Don had this enough to put forward in this cost presentation. So you can see just how visionary I think this man was. Next chart, please. So let's jump in. Let's get some interaction. Let's get some hands raised, and well, let's start with the design quotes. And I want to choose the second one there, and I'll just kind of stumble through it here. If you make something per the drawing and it works, and if you make it every time exactly like the drawing says, it will always work. it will never not work. And then during his oral history, he was allowed to go back and look at the text, and he inserted these things after his, first take. So unless you exceed the design conditions, that's his words. That's his words. It only does not work when somebody does something that's not per the drawing. So, I kind of think about this and think, okay, very interesting. We have a lot of engineers in SI, and I'd like to go ahead and open the floor to see, does anyone have any thoughts about that? Any experiences? I know for myself that sometimes the drawings have errors, and those errors are introduced maybe by the human element, but, what about this thought about just build to the print? Any thoughts on that to the floor? Okay, I'm not seeing any hands being raised. So we can move on. Oh, okay. Angela, please.
That's my question. Was this taught them all in drawings, or this was just one of his main way of just conceptualizing his ideas?
I would say that he was involved in the recovery of Apollo 13 when he was one of the key. He was like the manager of the room. So, you think about what environment that was in when you had a time crunch, you had to solve these little things at a time. So, I kind of think some of that came out of that, where he knew he could revert to a drawing or a systems level expert, and that they could trust that, hey, that vehicle was, this, and we could use the duct tape that the guy got, and we can use this air filter, and we could tape it on, and, we can do certain things. So I think, this probably came about based on his experience of seeing that, how important it is to be able to trust your drawings. Does that kind of answer your question, or elicit some more thoughts by others?
Yeah, that kind of answers my question. What I kind of like is the first drawing that you had shown when I saw that. For me personally, it makes it easier for me to understand what an engineer is trying to communicate. This is the first time I've ever seen that, you know what I'm saying? Because usually when I see what an engineer writes, it's like they take a paragraph and write 2 books out of it. I just saw one simple drawing and I got it. So I really appreciate that, you know what I'm saying? And I'm hoping he's not the only one that done that. There's other people that has done the same thing.
That is a real good point. You bring about like the language of engineering, right? Our language truly is the drawing, if you think about it. And sometimes when we're doing emails and we're asking about like this or that, or how is this, or what the convey, maybe it would have been better, or had a better efficient use of emails is to just say, here's the drawing, and take a look at that. But we also have to realize there's office people that maybe were never trained in DoD 100 standards. Greg, please, I see your hand up. Go ahead.
I guess, I have the benefit of having seen the charts and worked a little bit with this before we got to today. But I think we're gonna see a little bit of a common theme here. If you look at the second paragraph and you look at what the words are, when you say things like, and if you make it every time exactly like what the drawing says. So the word exactly there is a challenge, right? In manufacturing, can things really be exact? And in manufacturing, with respect to duplicity, can it be duplicated exactly every time? Then, of course, within manufacturing, we have the people in the loop. And so people are, and machinery is fallible. And so while I understand the engineering drawing, and the engineering drawing is theoretical, when you actually want to put that into being, sometimes I think it doesn't quite work out exactly and there's that word again, like you had intended.
Thank you for that, Greg. Very good comment. Scott, please.
More of an observation than anything else. I just find the interesting that the statement about engineering and the drawing and everything, and the fact that he was the man in the room on Apollo 13 when they did the forensics of Apollo 13, it was actually a design flaw per the drawing that was identified as the anomaly on the capsule. So just more of an observation about that and how it kind of translates with this quote.
Scott, that's a very good observation, because now you're pointing at it was built per the drawing, but it was a design flaw. Very interesting. Any others? I think before I get the move along from Laura, I think we'll go ahead and ask for the next chart, please. Human in the loop. Okay, so I think it was the second one that I liked. Well, I can get through both of them pretty quick. So you see, in some respects, I don't have a very high regard for the person in any system. There's, I love it. Straight speak, man. Don grew up on a farm, from what I've read, and those farmers, straight speak. The system should be designed such you don't need people. And then below, he says, see, there were good people like that. So I must tell you that because of those people, that's why we are where we are, and we got where we are. But a lot of these people, hey, they're not recognized any place. It's hard to recognize them. You almost can't, see? The line's so long, it would take forever. And for whatever purpose, well, it doesn't end up. See a point here, a point there, and you think that's what it is. So I love that I purposely chose these two because they're like on both ends, right? He's saying, hey, design the system without the person, but in the same respect, and below, he's saying, we couldn't get where we are or were without all these people, all the cogs. And the cogs are the people that really are not recognized. They're not really, but they're there working day in, day out, for the effort, for the mission. So I just love the idea of where in one sense you'd say, wow, the guy doesn't like people. But then in the second one, you can just see, his love for all these people that did all this immense work, and saying the line's too long. I love that. So I'd like to open it up.
Hey Kevin, it's Kristen. Yeah, this is one of the ones I was helping you with. So I have a couple of thoughts I'll add. When I was kind of looking at this, at his quotes, kind of in relation to this topic, he made several good points applicable to our aerospace environment, where the design was key and what was important. And so just thinking about the Mercury and even the shuttle, where the spacecraft, where he was saying, the spacecraft could pretty much fly itself. So I'll kind of paraphrase the little anecdote he had. Computers never get tired. They don't have to deal with emotions, and they're always there, available to perform. So I thought that was kind of, an interesting way to look at it. That's kind of one of his points on the topic. And then, you brought up a good point. Then on the flip side, he did kind of see the flip side and say, hey, I'm not saying humans aren't important. We wouldn't be where we are, without them. And he was acknowledging a lot of the smart folks he worked with. So it's definitely some interesting thoughts.
Kristen, go ahead and moderate this side, please. Thank you. I kind of ran roughshod over you. Oh,
no problems. Yeah. So, are there any thoughts or any experiences out there with, I guess, this human in the loop idea? Have people noticed anything in their own experiences where maybe it was good to be automated, or maybe, human in the loop wouldn't have worked as well? Any thoughts out there? And you can just use the raise your hand function if you got it. And go ahead, Kevin, if you got a thought yourself on this one.
Yeah, what the heck? I'm a talker. I think sometimes if you get too many humans, you get the telephone game, right? So maybe there's a way to say, I don't have a regard for, you know, human in the system. Well, what maybe too many humans in the system. So that's a thought I had. And then also talking about NASA and how we have the difference between probes. You know, you look at what's going on Mars with those rovers and stuff. The only human in the loop is the one back there kind of taking the data, and if the car isn't self-programmed or does something crazy, they get in. But otherwise, they've made these probes now, these rovers, where they make their own decisions with artificial intelligence. So I mean, you can open up this whole thing about artificial intelligence. You're kind of eliminating the human. You know, Tesla cars, right? Tesla cars are driving around feeding into a database so that the Tesla car that comes, if they put up construction barrels, they can self-drive because the car before them told them, hey, there's construction this morning.
Yeah, good point. Yeah, no, I like the analogy to thinking about in today's environment, the next evolution in the all this self-driving stuff. Where do you draw the line at having the human in the loop versus not? I know they've kind of got this quasi in the middle state right now where people are driving, but it's assisted, it's not fully automated. And what if you go fully automated? How do you put the correct algorithms and thought behind that computer software for it to make the right decisions? So I mean, it's kind of interesting analogy from our aerospace environment to today's car environment. Any other good thoughts out there? Angelo?
I'm sorry. Yes, just to add to that, even when you look now at the Walmarts, the Publix, I mean, they got automated checkout systems. You know, when you look back at what this gentleman wrote way back there, he was already ahead of his time. You know, with this type of thinking when it comes as far as AI. You know, so I just wanted to add those things on there.
Well, thanks all. I know we got several categories. If you guys want to move on to the next one, we can do that, Kevin. And Laura, if you want to help us get to the next slide.
Okay, thank you very much, Kristen. So integration quotes, these get kind of wordy and a little bit of an eye chart, but I'm going to drop down to the last one. It's an easy one to read. So it's simply that, and most people say, I don't know what the interfaces are. Well, you shouldn't be designing it if you don't know the interfaces. And further up, a couple of ones up, you can read them on your own. But he talks about, like, if there's 3 pieces, each person takes a piece. You know, that's our environment. That's how we have these contractors keeping our multi-user spaceport running, right? We have these contractors. So these interfaces, the way I look at it, is so critical that us as the NASA people, we are the bridge. We are the only ones that can help these contractors succeed by finding these areas where there's the breaks. And in a pure engineering sense, I like to think of it as the interface control document. Engineers know the ICDs and a lot of shuttle workers and that, you know, oftentimes the problems were in the ICDs. They were hard to read. They are, you know, half of them were written by one contractor, the other half was written by the other, and then the integration guy tried to put it all together on one drawing. So if you ever wanted, I remember as a young engineer in the 90s, that was one of the things the guy says, you really want to know about some more of the problems are? And he handed me a bunch of ICDs and said, just go off and try to, you know, try to find the errors in these things. And it was an interesting assignment as a young engineer. So yeah, it's the handshaking, it's the contract, so to speak, between the interfaces. And what Don is saying here is like going, if you don't understand this, it almost seems to me like he's saying, you know, don't even try. You're not gonna succeed. You know, so that's just a few thoughts. Maybe we can get some hands raised. Okay, go ahead, Kristen, please.
Yeah, and reading these quotes here I would just say it's kind of interesting to think about. So I mean, I came on during the shuttle program, and of course now we're processing SLS. So if you just think about the transition to the programs, I think it's interesting to think about the management philosophy behind how do we do that integrated testing? Because it seems, I don't have any direct examples off the top of my head, but it does seem like we've had different philosophies along the way about what type of tests we do or how full up of an integrated test we do. You know, sometimes maybe we buy into more risk than other times, and you think about the transition from the different programs and how we operated. So I would just say that definitely is different. It hasn't been a one size fits all from the way I've observed it over the, you know, different programs. Other people probably have better insight into that than I do.
Thank you for that, Kristen. Jeff, please.
Yeah, I was just going to add to that, and as an example, you know, during the space station days, space station was intended to be a ship and shoot kind of process, and with all the international partners that we had, and as you pointed out, all the various drawings that they did on their side versus the opposite side, and the ICDs, you know, not necessarily matching up, but it really wasn't until all the parts got to Kennedy, and we, as you stated, were the integrators. When we took cable A and tried to attach it to cable B from two different partners, we found that they didn't fit, you know, and was a simple fix back at the plants, but it wasn't found until it got to Kennedy to do integration. And we found we had, you know, two male connectors, and, you know, had that part really truly been the ship and shoot, and they tried to assemble that on orbit, would have been an epic fail. So just, you know, more integration stories.
And Jeff, thank you for that story. That really drives it home, right? Real world example, you know, two male connectors, you know, yeah, that really drives it home. And this picture, I like the picture that was chosen. You know, if you want, that's kind of, you know, sums up some of this too. And what an amazing accomplishment for KSC, right? And the station to literally, this incredible machine, essentially, they brought it together, all these teams of people, and it's up there, you know, doing some phenomenal science. So hats off. Scott, please.
Yeah, I think this piece is especially appropriate for our group. I mean, it's something that we experience almost every day, right? Whether it's a SpaceX launch with a moving target and trying to get all those pieces to play together and be in the right place, or a transport across, you know, anywhere on center, or something as simple as trying to coordinate a new facility for one of our partners. Maybe not as simple, but, you know, we've got a process defined for that. And knowing what those interfaces are, like the last line says, and understanding what those interfaces are and trying to get them all to play together. I mean, that we live that every single day in our group. So yes, very much so.
And Greg, please.
Yeah, and you know, Scott, I really appreciate those words, and I was thinking, you know, of all the charts, I probably ought to say something about this chart, and all those points are extremely valid. And of course, the thing that I started working yesterday is the next GN2 outage in the LC39 area, and just already started to work with the different customer advocates and the different customers, already getting the challenges about how it's all going to fit together. And if it fits together, it all works pretty simply and pretty straightforward. But when it doesn't fit together well, that's when things start to get very complicated. So we'll see in the end how this turns out with respect to this specific outage. But all good points, and greatly appreciate you bringing them out.
Excellent, Greg. I'd like to piggyback on that, on observation about the master integrator, right? The conductor, especially in this work from home environment. Imagine, if you will, if you were the master conductor of this integration task and you are asking for information, you're coordinating this symphony, and the person doesn't really, they're not timely in their response, they're not accurate, they didn't go off and answer the specific question that you needed. Just imagine, if you will, that your responsibility is the conductor, and you're trying to do that. You know, at one piece and the whole orchestra, one violin playing at the wrong tune, the entire orchestra is put off and the audience can hear it and know right away. So please, if you will, when you get these assignments from these people that are asking for timely and read the emails, make sure you understand what the question is and answer the question, right? Answer it in a timely manner. If there's some reason you can't do something in a timely manner and it's not specified in the time frame, ask what the time frame is of the data or the information that the integrator is asking for. You know, you may not understand or know the symphony that this person is working to try to pull off. And so, you know, just one of those things, hats off to those people that are the conductors, because it can't be easy. Any other discussion? I think we're probably making pretty good time. You guys are a quiet crowd, you know. I kind of expected more hands. So we'll go to trust quotes. These now we're getting into some really interesting, and I want to read both these since we're doing pretty good on time. We may end up actually adjourning early, but that's fine. They were good people. They were good engineers, but it was the first time I ever found people who really didn't tell the truth, or they would distort things. They would try to slip things by. But you see, I could understand why that was too, because see, they were in the business of making money. And the Langley Research Center was not in the business of making money. The Langley Research Center was actually to find out things, you know, and how to make things better, or how to improve whatever it was you were messing with in aerodynamics, right? That's NASA, right? That's NASA. That's Langley, that's KSC, that's Ames. That's your government, you know, working for the good of all mankind. So that's really insightful. And the second one, like I said in the beginning, when I told you about one of the biggest shocks with me was McDonnell Douglas, and we didn't have to redact this because they're no longer in business, right? But you know, in the beginning, how some of those people were, particularly the people in managerial positions, how they would distort, and that to me was very shocking. Again, remember where Don grew up, you know, on a farm, right? Straight shooter, handshake was your bond, that kind of stuff. That was a negative mentor. Is how not to be. You know, there's how to be, and then there's how not to be. What I found interesting about this final quote was the term negative mentor. That was the first I've ever read it or heard it. Others I think have, but that was kind of an interesting thing. So, you know, just the interesting thing about the profit, right? We have that. That's our environment. We're doing for the benefit of all, right? The NASA motto, although I've done research, it's not the true NASA motto, but it's on Wikipedia, but it's not the NASA motto. But anyway, for the benefit of all. And then there's the people we have to interface and work with, the contractors that do have a profit motive. So I think it's incumbent upon us as the NASA to remember, keep that in the back of our minds. Obviously, you can see Don had dealt with that and seen that, and with his straight speak, you know, he said that in his oral history. So I'd like to open the floor. So Greg, please.
Yeah, it's too bad. It's too bad Mike Cianelli isn't here, because I think this would resonate extremely significantly with him and the lessons learned program with respect to the accidents and things that we've had in our agency. And I think a lot of the times this kind of issue comes to bear. And if you know, Kristen facilitated the last lunch and learn we had associated with the Challenger accident, and a lot of information came out in the Challenger accident about people not being truthful, or about people maybe hiding things that that were in the end impactful, especially to 7 families. So and us as an agency, but. With respect to the profit versus not, of course, today in our multi-user spaceport, we certainly see the difference between a government that really doesn't work based on profit or the bottom line, and a multitude of commercial partners that's exactly what motivates them, and that is their bottom line or the profit. And so we can see the difference of getting things done between those two groups of people, and they are at times fairly significant. The only last point I would make with respect to the negative mentoring, you know, I never called it negative mentoring, but I always taught my kids that everyone you meet is a teacher to you, right? You can learn from everyone you meet. You can certain things and how to be, and unfortunately, with some people, you can learn exactly how not to be, which is interesting to hear Don write that down, because if Shane and Lindsay were here, they would tell you that I have taught them that their entire lives. So, thanks, Kevin.
Thank you for that, Greg. Others, please.
I love that you can learn from everyone you meet. I love that.
Thank you, Kathy. I'm going to play a little Jeopardy music because we're doing really good on time. We're not moving until we get one more hand up.
Kevin, I don't want to go backwards, but Christine Okrepke had a question before you flipped charts. So I didn't know if Christine wanted to ask her question or make her point still or not.
It doesn't matter. I don't want to take away from this particular discussion.
We're flying along.
Okay. Well, I just wanted to, on that with the integration, I definitely have a lot of stories to tell, but I can tell you that the whole thing about, I worked a lot with Orion and Orion Flight Software, so Lockheed Martin folks, and it was difficult because they did not understand at all what we did here at KSC. So, and with, you have 3 different entities working on schedules and trying to tell them, we need this information so we can do our job, when, oh, by the way, they don't answer to us, they answer to a different entity, Orion program, not EGS program. And not even, some of these people, we had to explain to them what an OMRS was. They didn't even know what that was. So I completely hear what everyone's saying about, like you mentioned about the master scheduler and for the requests. It's definitely challenging, and that's one thing that it's difficult to when you have to work with folks that don't know what you're doing. So like you said, like it said, if you don't have that understanding, if you don't the integration and know the other pieces, how can you expect to really work it and understand it? And that was a lot of what I had to work with the Lockheed Martin Flight Software folks when it came to Orion and then EGS and the folks developing the software for ground testing. So I just wanted to kind of throw that in there as even further examples how integration is definitely key to success of anything.
Christine, that is very valuable. I'm glad you brought up. Is absolutely worth talking a little bit more about. I would actually like to pick your brain because I'd like to know how did you handle that, and what approach or what did you do to try to educate them? I mean, you obviously identified that environment early on. You probably struggled with it, I would imagine, the entire time. But were there some things that we could take away? Because SI, it's what we're all about, right? So please expand on that.
Sure. So it really was about developing a good, trustful, so you have the trust here, the trust relationship with the Orion program people. So I had the backing of them a lot of times because of the relationships that I developed with them, that when I needed information and I needed it, yesterday, basically, they would help me get that. They would help set up the meetings that the Lockheed Martin folks said that they were too busy to do, which, I mean, ultimately they probably were, but these answers did need to get answered. So, so really it was a lot of developing the relationship with the people and having that to get kind of the backing from the Orion program. And then once I was able to work with them directly, you know, they were a little bit more open and they knew who I was. It was, you know, just getting my name out within the flight software team to help me get what we needed for our EGS folks.
So if I was to summarize what I heard you say is there was no quick fix, right? That in fact, you had to struggle. You had to essentially be patient and give time to allow them to understand your position. And then you were able to be successful or at least, you know, success to a moderate level. But it took time. So you had to persevere. Essentially, what I heard you say is that I couldn't fix the situation. I had to give it time and be patient and struggle and persevere until the relationship was established.
Right. Yeah,
Wow.
for sure. And I mean, there's even a struggle now, but and also was a lot of working compromise as far as, okay, if you can give us this, if you can at least give, you know, like, for example, flight software releases, if we could at least get an engineering release a couple weeks ahead of time, even though it's not the official copy, then, you know, can we live with that? And so kind of working those compromises and negotiations, that was also part of it too. But yeah, definitely the struggle was real.
Wow. So the final element there was persevere and even become a diplomat and a broker of compromises.
Mm-hmm.
Wow. And, you know, I tend to, I like the word colleague, and I kind of harp on that. I know a few people that know me, you know, I tend to think the struggle wouldn't be so difficult if we just had a basic understanding of the roles and responsibilities of a colleague. So I'll just kind of float that out there. But wonderful, wonderful. Thank you so much for that. That was well worth that time. Thank you, Christine. Very insightful.
Thanks.
Anyone else like to piggyback on that or wrap that up?
I'll just say, so Christine's a great customer advocate for her new partner, her new her new mission partner. So things didn't get easier when she transitioned out of Lockheed Martin world and into Boeing world. So,
and at least she has a skill set.
Yeah, exactly. I'll just say that now I hope the group has an even stronger understanding of why we asked Christine to come and be a part of our organization. Because the skill set that she had developed during there is so integral to how we do business on the center in the multi-use spaceport.
Thank you, Scott. Wonderful, wonderful, great. This is going good. We got about 6 more minutes. So before we give our little free flow to Sean, I believe this one is yours, Kristen.
Hey, thanks, Kevin. All right, yeah, so another interesting topic we have for you guys. Don talked about redundancy. So a couple of quotes here show that Don didn't always think redundancy was necessarily smart or needed. And kind of going through the oral history, kind of seemed to me his main point was the significant cost and weight of all that redundancy, that you have to be able to get it up into orbit. So, I mean, so that was definitely a big concern. He was really pinging on focusing on the design and making it right. He also talked about the safety factors and strengthening over designing some things. But of course, that has a lot of cost as well. And Don acknowledged that in regards to human space flight, there's that emotional component and management not wanting to take risks, and hence all the redundancy that we built into our, numerous programs over the years. So I thought it was some interesting points. Obviously, redundancy is something very, very prevalent in what NASA, has relied on over the years. He was one example Don was talking about, just thinking of the control boxes in the shuttle or something. Okay, well, if you design it right, okay, maybe you just need one, but if you're gonna have the redundancy, well, you can't just have two because then you don't know which one to believe. Well, then if you have a third, then okay, well, what if you get the signal on this one that says this and these two, which one do you believe again? Okay, so let's have 5. And he was just kind of exaggerating on the fact that, where do you stop? You just get more and more, and that's not very easy in terms of cost and weight and accomplishing our mission. So, so what experiences might others have out there? Thoughts on this topic? Go ahead, Scott.
Yeah, I think this really goes to the, you often hear us say better is the enemy of good enough. So, you could design better. Designing better, though, sometimes comes with a significant cost or a significant penalty to design better. So now you have to institute redundancy when you go with a good enough plan. I think that's probably one of the factors that goes into why we rely on redundancy. I don't know. Others?
Greg, go ahead.
Yeah, I will say in the my understanding of the, not that I was here, but my understanding of the Apollo program was they didn't do a lot of integrated testing, and they did depend on redundancy to win over a bad day. So, I mean, this is the time frame that Don represents, but I recall lots of discussion in the Apollo about the Apollo program dealing with a lot of different places, a lot of different locations around the states, building a lot of different things. Here we get into the interface, the ICD questions again, but they depended on all that stuff coming together, and there wasn't a lot of time because of the national priority and the direction to be done by the end of the decade. And so there was the absolute dependency on redundancy to cover your where, as a result of, one, not having integrated testing, two, maybe not what, like Scott said, not designing things to too many more decimal places and exponents. So there's sometimes where I think there's a little bit of controversy or him not necessarily agreeing with himself on these kinds of things.
Yeah, thanks, Greg. Jeff? I think you might be muted if you were talking, Jeff.
Oh, sorry about that. I just think it would be interesting to be a fly on the wall, kind of leaning on what Scott said. I just wonder, given the urgency or even in today's world, if we rely so much on redundancy as a norm that we don't do the due diligence in the initial design. Are we cutting corners in doing a good job as in the initial design, as opposed to a good enough because we know we're going to have redundancy? And then you get into everything he said about, well, now you've got more weight and more piece parts and more failure potential. And I just wonder the thought process sometimes in the design world, if they go with good enough because we know that we're going to have 2 more boxes that are doing the same thing.
Yeah, good point. And Kevin?
I think that's so spot on. I really like Jeff's comment. I just wanted to piggyback on that. I really think that's spot on, because if you think, for instance, if you're as a designer, say, hey, you know what? If we carry it out, if we work another 6 months on this and really make this a tight design, hey guys, I pretty much know this thing won't fail. So absolutely, I like what Jeff just said about, are we maybe not designing as good as we could? Thanks.
Thanks, Kevin. I believe Greg.
Yeah, I guess I would be concerned about carrying all this a little as far as what we might be thinking. And so if I develop a box that's good enough, and I design redundancy, so now I have 2 or even 3 boxes that are good enough. Have I really gained anything? I mean, again, you can carry this too far, but if I'm only designing to good enough or building to good enough, and I have redundancy, then if my redundancy is equally as good enough, did I really achieve what I intended to achieve by redundancy?
Well, thanks, guys. If there's no more comments, I think it might be time to turn it back over to Kevin. I think that was the end of our main topics. Kevin, if you want me to turn it back over to you.
Thank you, Chris. I think we got one more general, and we'll be quick about this one. Next chart, please. Yeah, other quotes. And so you know what a sine curve looks like, or a wave, those plus and minuses around the mean. What goes up, you know what's going to go up, and then it comes down, it'll oscillate. But things like that happen. It's the dynamics of nature. So it is kind of interesting. I think he's spot on. In engineering, we learn about dampening and oscillations, kind of, all different types of things. And I chose this chart, Simba, the circle of life, right? Basically, I think Don is saying, the circle of life. So just a general quote that I really liked. Any comments before we go to our free form on this, or the circle of life quote? If not, I think we got one more chart that is near and dear to my heart. Many of you that are in the 50s will recognize this from Saturday morning. So now I'd like to go ahead and ask Sean, if you would please just turn on the camera and free form. We'd love to hear anything you'd have to say in these final 10 minutes or so. Thank you.
Thanks. This is interesting. I don't have much to say and much to contribute here. I just want to say that it's fascinating to me how much Dad's the quotes you use and his thinking and his way of thinking about the world and way about thinking about what you guys do at the Space Center. It's fascinating, and it's relevant still. Other than beyond that, I have nothing else to add. Sorry.
Oh, no worries, Sean. No worries. We're just so glad to have you here and be a part of this. It's amazing, the things and the oral history. I would tell everyone online, if you haven't had a chance, you can kind of skim it, because I guess Don, he get him talking, probably. He's kind of like my dad, maybe, he can talk. And Don had a lot. I'm telling you, his life, it was amazing. There's a story in that oral history he tells. And Laura, I see your hand. I'll acknowledge. But there's the thing about, he wanted to build his own airplane, and it's beautifully told by Don himself about a Model A engine. Believe it or not, So go ahead, Laura, please.
Hi, Sean. I was wondering if you could just share what you know. I think the Apollo 13 challenge was probably the thing most people, even outside of the engineering field, have heard about. I'm wondering I don't know what you knew about what was going on then and how it impacted your family.
Oh yeah, we knew it. Of course, he was at Johnson Space Center, and I remember him not coming home for several days, being at the office only a few miles away. The same thing during the Skylab. When Skylab went up, and I believe it was him and Glenn Lunny are the ones that designed the emergency heat shield for that. Another event where he was gone, just once again a few miles away, but spending the night and several days at his office. And obviously, it was not unusual for him not to be around much. He was always traveling for work, obviously.
Yeah, I forgot about the heat shield. Yeah, amazing. Yeah. And any fun like a vacation where your dad did something, that you want to share, right? Because I don't want you to but is there anything that you remember as some vacation or something? I don't know.
There's lots of things, but I think one of the things that always struck me is, his whole life was physics, right? And he talked physics to his last dying days about it's all about physics. Everything's about physics. Well, that's fine. Although sometimes I think some of the ways he was using physics and some of the conversations we had, it was kind of a bit off the chart. But I think my brother would tell you the same thing. But whenever he went somewhere, be it on holiday or with family, like at my aunt and uncle's up Rhode Island, or visiting, other parts of our family around the country or whatever, and something went wrong, it was always up to him to take on the construction project to fix a sink that's clogged or do some such, replacing an electric connection that wasn't right. And so it ended up being something that should have been simple, would have been this entire redesign that was never ever completed. So that's typical dad. It was typical dad throughout his life, including a lot of things he built himself. And everything was always actually finished. It was just finished enough. But obviously that didn't apply to his work with the space program.
It's interesting how he notes, give me the amount of time I need, right? And so my understanding is he built his own blue water sailboat, right? So he had time, right? So he's like, well, it's probably still continuing to be tweaked, but when there was a time like, hey, we need to get Apollo 13 back, or we need to do a heat shield for space, he could finish it, absolutely. So do you have a story or anything about the boat? I know we have a few folks that like to boat. Do you have anything about did he literally from plans, or did he take a shell? I'd love to hear about the boat.
Right. So this is in the late 70s, I think 77. Dad was building this on the adjunct to our house down in Houston, the cinder block garage to put this giant 36-foot sailboat hull. The hull arrived was fiberglass hull. That was it. And he did everything himself. To put the ballast in the keel, he designed his own smelting for lead to boil that down and melt it down so we could put it into the keel. He brought all this, I don't know how many pounds of maybe close to tons of teak he had shipped from India for the deck and everything else. He did everything in that boat. And never actually got into the water. He passed away. Well, let me backtrack. When he moved to Florida, after my parents got divorced, the boat went with him. It was on the side of the house, and he was always working on it. Never fully quite completed. And his goal, the thing could have been in the water decades ago. He didn't want to put it in the water till it was completely finished to his spec. But of course, as he got older and his health declined, that was a bit too late for that. But it is in the water now. The boat's been sold. My brother and I sold the boat, and it's in the water. It went in the water last week, actually. And my brother was down there. My brother was down there. Yeah.
Amazing.
Yep.
Wow. Is it in the Texas area or Florida?
No, it's in Florida. It's down at the Cape Canaveral. Yeah.
Really?
Yeah.
Do you know the name of it so we can keep an eye out for it?
The Seahawk.
Say again, you broke up.
The Seahawk. Seahawk.
Seahawk.
Yeah.
Hey, anybody? There's a $1 to the first person that has a picture or a sighting of the Seahawk going out of the port. Kevin will pay. Wow, amazing! And what is it? What you said it was 30 some feet?
Yeah, actually, it was 32-foot west sail, which they don't make anymore. And Dad got that specific size for the vessel because he could sail into any port anywhere in the world. That was his goal, to have a boat that he could do.
That's the guy, right? He's looking at
Yeah.
all the specifications for the world.
Yes.
I mean, he's thinking, he's going like, all right, you know, the water is basically this earth, right? Amazing. His specification was the port in the world. Oh, I love it. I love it, man. I love it. Wow. That was the specification.
Yeah.
Wow. Amazing. Well, listen, folks, any closing thoughts or remarks? Otherwise, we'll wrap it up a few minutes early to allow you to get to your next meetings and such. Again, I want to thank Laura and Kristen, Greg Gaddis, Scott Coaster, a whole host, and of course, Sean this afternoon for providing this format for a great discussion.
My pleasure, and thanks for doing this. It was very interesting. I'm sure Dad would have approved.
That's all we needed to hear.
There's
All right,
already
folks.
a note in the there's already a note in the chat, but thank you, Kevin,